Let's build two of these. Let's build one of them rebuild one like a stock 290. Let's rebuild the other one and do everything that you can do to it, performance-wise. Let's put the 49 mil jug on it, the MS390 top end on it. Let's put a pop-up piston in it. Let's massage the ports a little bit and build a cool muffler for it. And nothing that we're gonna do here is gonna require like specialty tools or anything. We're not even really gonna change the port timing much, so we're not even gonna put a timing wheel on it. Along the way, I am gonna use some tooling and so that you do know what to check and how to check it, but for the most part, you don't need any specialty tooling to build this. You need a T27. And a couple sockets, and that's about it. Well, it's been a while since I've built one of these or worked on one of these, but essentially it's a lot of screws. There's I think there's 4 screws on the side, 2 on the bottom. This handle comes off. We're gonna do this all with a T27. You need a screwdriver and a couple sockets. Just start pulling this intake apart. That's gonna release the carb and everything. There's one fuel line. This saw was already missing the choke lever. So there's our carb. And then we're just gonna start running the rest of these screws out. We gotta pull the recoil off. If you guys have stink bugs by you, but they crawl into all the saws and stink them up. This is what we have to deal with now. We're gonna do the muffler. Even stink bugs in the muffler. Okay, then there's one AV mount up here and a carb boot here, and then our handle should come off. Don't lose all these little parts. I keep everything up here on this tray. You gotta pull this AV mount out up here. And then we've got the 2 wires for the kill switch. The carb boot's got to be tucked in there for that to want to come off. And then our impulse line will just pop off of the bottom of the cylinder down here and take that with it. These wires will pull through the grommet, handles off. Now we'll pull this intake divider off here. Go back to our T27. We're gonna leave the spark plug in for now. You'll see why. There it goes. Okay, so now we want to take the flywheel off and we want to take the clutch off. Let me take a break here real quick and suck up all these stink bugs. All right, so for the flywheel is standard thread, and by leaving the spark plug in, we should have enough compression. As long as it's not blown up too badly, we should have enough compression to be able to give us a hold back on that nut. So standard left thread to take off on the flywheel, and then to remove the flywheel, every steel saw is either going to use either the threaded insert style or just basically a cap that you're going to bead on. Otherwise, for other weird kind of flywheels and stuff, something like this, you might be able to slip in there, but that's not this one. For this style, we're just going to put on this thread protector, basically is what it is. And then we're going to back it off, maybe a half a turn. And then we're going to just take could probably just use a ball peen, or maybe even a dead blow. And what I do is I kind of pick the saw up a little bit by the flywheel. That pops right off. More stink bugs, who would have thought? And then for the clutch, I have a socket that I kind of ground, because you know how they kind of have a curved sockets, kind of have like a rounded edge on them. I ground this, I've kind of faced this socket off flat, so this can kind of sit on there nicely and not slip off. And this is going to be reverse thread, so you're going to go to the right to remove it. And that just spins right off to the right. Again, just using this motor could even be seized. I don't know, but all right, now we're real close to popping this clamshell out, and we do have a Molle OEM cylinder in here. We're just four more screws away, maybe 5. Well, we got 2 of them. Now I don't want to over torque these other 2 screws. These ones are stuck in there really good. I don't know if they have thread sealant on or thread locker on them or what. I got 2 of them loose. The other 2, they're in there really good. And I don't want to over torque these and strip out the Torx head on it. So what I'm going to do is put my heat gun right here and just heat this material up in case, without melting any plastic or anything like that. We're just going to try to put some heat right here on the aluminum and see if these will pop out then. All right, I burned up some stink bugs, but I put some heat up in here. Put some heat up in here and try to heat that aluminum up, and then we'll see, is that going to do the trick for us? Oh yeah, pops right out. All right, now on these I forgot that there is one of the bar studs that is connected to the bottom of the clamshell. So this bar stud will have to come out in order to release that clamshell. So, well, like I said, it's been a while since I worked on one of these, and we're trying to do this quickly. So what I've done in the past is I've taken 2 steel bar nuts and crank that first one down on there. Then take a second one, kind of lock it to it. There it goes. Now our clamshell's loose. How about that? It always helps to take all the bolts off. So here's our clamshell. Essentially what this is, it's a crankshaft strapped to the bottom of the cylinder. That is an economy chainsaw. That is a non-professional saw. So here's our crank bearings and our seals and our crankshaft. And our failed top end. Look at that. So now we have to decide if this cylinder is salvageable. If not, we're just going to go ahead and replace it with some aftermarket parts. So what I'm doing here is applying some muriatic acid, some 31% muriatic acid on just a couple spots here where my sandpaper was not releasing that aluminum transfer off. So we're gonna melt, and the muriatic acid does not affect the plating at all. And then what I'm gonna do is put my flex hone in it, and we're gonna hone it, and then we'll make a final decision on whether or not this cylinder is good. If it's good, it's good, and we're gonna run it. If the plating's good and if the plating is not damaged, it's not damaged, and we can put a new piston in, and we can run this 290 and be able to use. We want to use as many OEM parts as we have. So if we can reuse this OEM cylinder, perfect. Okay, so here's our final verdict on our 290 cylinder. So there's still a little bit of aluminum that we could remove from right below that exhaust port. But the problem is these lines up here. And these lines, whenever you score a piston, you're gonna have some lines. And so what you have to do is make a judgment call on whether those lines are too deep to where your ring is not gonna be able to hold compression, or are the lines more just cosmetic, or are they just wear marks? Because there's always going to be wear marks. So you got to figure out. And I've decided these lines are too deep. I've kind of run my fingernail on them, and I can feel that it catches. If it catches a little bit, if you feel a little resistance, yep. See how it's stopping the screwdriver right there? That's too deep. So this cylinder is junk. All right, so where did we leave off with these clammies? Cylinders are no good. Everything's scored up. We got to go all replacement parts. So what these replacement parts are is Duke's brand from Saw Salvage. Basically, cheapo saws are going to get cheapo badipo parts. So these are the perfect saws for when your buddies are like, oh dude, do you got any like really cheap saws? You got anything for sale for really cheap? Oh, I got the perfect saw for you. I got the perfect one, bud. So the 390 aftermarket cylinder, basically 49 mil. Let's clean this up, because these are not that great stock, or the way that they come, they're not that great. We need to fix some things up. So I'm not going to put a timing wheel on. Why am I not going to put a timing wheel on? Well, because I really don't care what the port timing is. And what I mean by that is, regardless of if the exhaust port was at 100 or 105, opening and closing, it doesn't matter. Like, what we're going to do is we're going to leave all the torque in it that we can get, and even add a little bit with a little button top, a little pop-up, and we're going to flow all these ports. We're going to flow all these ports open and shape them so that we can try to maintain a nice RPM in the cut. These saws, one thing you don't want to do is take too much torque out of them. And anytime that you're going to open up, start hogging out ports, and anytime you're going to start making big durations, you're taking torque out of the saw. These don't have a lot to give. And so the build plan for this is maximize torque and then flow what we can safely. Flow what we can and efficiently. I'm not going to sit here for hours and work. this aftermarket clamshell cylinder. We're gonna be efficient with our work, try to do this very quickly, and make good flow gains. So on the intake port, the first thing you're gonna notice is there's a big booger. There's a big booger on the bottom of the intake port. And that's very common. That's very common that there's a booger there. Even stock, even OEM cylinders will have this ridge that runs across the bottom. I like to take that ridge off and clean this up. And I also don't love the shape of this port. When this intake port opens, you'll notice it's got a big U shape to it. Okay? It's got a big U shape to it. And I want to do all my business down here in this first part that opens up. I want to do all my business down here. I want to maximize all my flow down here because essentially we want to get it down, right? We want to get the flow we want to get it going down because it has to go down into the case, into the little mini case we have here, and then up into the transfers. And we don't want to lower the intake more than we have to, because anytime we lower the intake, we're reducing. Anytime we lower the intake port or we raise the upper transfer ports, we're actually reducing the capacity of the engine. We're reducing how much air we can pump with our case capacity. So we are going to leave the height, we're going to take that bugger off, and we're going to leave the height of that intake right where it's at after we take the booger off, but we're going to shape it so that we can get a big dump of charge. We want to take all that charge right at the bottom as much as we can. And also, we don't want to widen it too much on the top or at all, because the ring ends, I believe, the ring ends are going to fall into the intake port if we do that. You can see, oh, there's a ring end right there. So if that's bottom dead center right there, and we go and grind the top of this port, what's going to happen? Little Mr. Ring End is going to fall in to the intake. We're going to hook a ring. So we're going to do all of our business. There it is. We're going to do all of our business down here at the bottom. On the transfers, you know, these transfers kind of suck. But what we can do is clean them up and finesse them and get them to flow. So what you'll notice, so the first thing I noticed was, okay, let's say our transfers open about here. Well, look at this. Look at this right here. Look at this nasty stuff on the bottom of the piston. We want to flow, and remember, this is a clamshell, so a lot of our volume is above the crankshaft. So we need to get it all up into this port, and we need to be able to turn this corner, and you can see that lip, this nasty lip that really provides no structure, as well as even into the skirt. You can see how the skirt would impinge on that cloud getting turning the corner. See that? Right here. We want to get this volume dumped into here. Well, we don't want any sharp edges and obstructions in the way of getting there. So, you know, and you can certainly work the cylinder up as much as you want. I mean, I've seen guys hog all this out and this out, but remember, just keep in mind that this is bearing stability, this is bearing stability, this is bearing stability, and this is piston stability, all of this. Now there is a knife edge, you can see, there is a knife edge here and there's a knife edge here. So what we'll probably do is take that knife edge off and help that flow in as well that way. The exhaust port. The exhaust port essentially is a big rectangle. You know, a flat top does perform well, but you know, a square shape is not ideal. So what I would like to do is add a little radius to the sides, and we're not going to widen it too much, but I would like to take a little something out of these edges and kind of radius them in to the top. And then we'll add a little bit of better chamfering to the inside of that exhaust port. There is a chamfering, but it's not always guaranteed that it's going to be the best surface in here. So let's provide a little better chamfering, and then we can run a hole in through this after our port work's done as well. And this isn't going to be grinded. I'll go in here with a drum sander and kind of shape this with a drum sander, and we'll kind of sand it, and then we can put a polish. It only takes a couple minutes to put a polishing bit on and polish that exhaust port out. Now on the muffler, I want to do the muffler a little differently. A lot of times what people do, and I've done this before, is they cut this baffle out or drill holes in this baffle. And essentially what you're doing is you're making a little shorty pipe, a very, very small pipe. What I would like to do for this one is utilize, because there's about a dozen holes on the top and bottom of this first chamber. There's about a dozen holes. And I think those 2 dozen holes is gonna flow just fine. I think where the restriction is out here, where everything has to flow through these 4 holes. So what I think I'm gonna do with this muffler on our modded 390 is just take this out and take this out and really let that flow, and then modify our cover and open up the port on our cover nice and big all the way around, and then maybe even cut that back into a nice slot so we can really get this thing barking. And honestly, you know, like I said, you can absolutely cut or drill this baffle, but whenever I do that, it honestly, it just sounds like the muffler fell off. It doesn't sound good. You're not utilizing any of the volume. Okay, so we got our work done. Let's take a look at the cylinder. Remember, the intake port had a real deep V shape to it, and now I gave a little bit more size without intentionally lowering it much. I deboogered it. I took that booger and that ridge off on the bottom. And now I'd like to think it has kind of a nice oval shape. I didn't remove any material on probably the top quarter of it, maybe the top half, depending on how you look at it. I want all that material in there. So everything that I manipulated was on the bottom, and all these ports really just got hit with, I think I used about three of these drum sander bits. So that's what it took to do all of this, including the exhaust port, which this is what you want it to look like. Remember, we went in and did we gave a little radius to the side, because remember, this thing is it was like a rectangle. It was like a rectangle stock. So we did a little radius on the sides, and then I went and did a polish. So for that, you're gonna need more bits and parts and pieces, but yeah, and transfers. you know, like I said, I wasn't going to do a whole heck of a lot. I wanted this to just be a quick, easy port job. I took that knife edge off here and here to try to open up the bottom of these lowers. And I'm not touching anything on the top for multiple reasons. But that's basically it. The piston got exactly what I said. I was going to work those boogers off. I was going to work those boogers off the bottom of the piston right here and into the sleeve to allow just really nice clean flow as we go around this piston and into the lower transfers. And muffler, just like we talked about, muffler got these slots cut out. You can see those perforations. There's like a dozen holes on the top and bottom. Those are going to dump into these slots that we cut. And then I opened up the exit port on the cover. You know, and we can always do more, but that's kind of where I'm at for right now. That's got to be flowing at least twice as well as what it was. So that's the muffler. All right, time to install. If we did work to our ports, what we need to do is kind of chamfer our ports. So anytime you cut or work a port, you're going to get a sharp edge where you worked it into the cylinder. And we want a nice smooth transition or an angled chamfer. This isn't necessarily a how-to port video. This is more just we're talking about what we're specifically doing to this cylinder. But it is important, if you don't have the tooling, like a mini, if you don't have like a mini angle grinder in order to run like a bit like one of these, this is what I use. I call it a football. It's kind of shaped like a football. That's what I use to work the chamfer. There's a 40 grit and a 120 grit, I think. I use the 120 grit for doing the chamfer, and then you'll come in here with your little mini and you'll just kind of work those sharp edges with this till you get a nice little chamfer. If you don't have that, you know what you could probably do is just take some like 240 grit sandpaper, and you can just kind of like do it by hand. You know, you rip off some little pieces and stick it right on your finger and just go in there and manually chamfer. Just go in there and manually chamfer. You ain't gonna hurt the plating. But you will hurt the plating if you hook a ring. So you don't want to hook a ring. So I would always put a small little curved chamfer into your port. And that way your ring can transition on and off of that port smoothly and not cause premature wear, and hopefully not hook a ring. And then after you have your chamfering done and your port's kind of smooth, the inside of your port's smooth and sanded out, what I do is I run a flex hone through. I bought this flex hone on clearance for I think 15 bucks. This is aluminum oxide. I forget what grit they call this, but you can just put some 2-stroke oil on it, and then you're gonna spin that with a drill, and that very lightly. Do this very lightly. You're trying to just cross hatch and push this in very lightly, maybe 10 times. Don't camp out on it, and don't run it dry. Make sure you put some 2-stroke oil on it or something, or some honing oil if you have that. But I always like to run the flex hone, it's called. Just a quick flex hone through a new build. Sorry, don't mean to make you dizzy here, but you can see there's a chamfer on the ports. It's kind of kind of what you want it to look like. This is really bad camera work. I do apologize. If you can see that, I got it all washed up. Okay, so before we install, we have to remove our old bearings off the crankshaft. The piston removal is pretty self-explanatory. Pull the 2 wrist pin clips, tap the wrist pin out. Piston comes right off. But in order to, I'm going to assume you don't have like a bearing pulling tool or anything like that. So all you got to do is you got to get it chucked up on something like this. It's going to hold two sides of it, and they'll come right off. And if they're real stubborn, get a heat gun on them. All right, then for bearings, you've got 3 choices basically. You can go with the aftermarket. We're just going to call them the aftermarket bearings that come with like a Duke's kit, or at most any eBay, Amazon kit, and they are made in the C place. We won't say any more than that. Or you can go with an SKF. An SKF is OEM equivalent quality bearing. Or you can take your chances with the OEM bearings that you took out. You know, I can feel, as I spin this bearing that I took out, I can feel that it's got some sticky points to it. You know, it doesn't roll quite as smooth as these new ones. It's got some little lumpy spots to it, or you'll just feel it's not rolling quite as smooth. So we're going to discard the old OEM, and then we're going to either put in the SKF or the made in C place bearings, and they both look, I mean, visually they look the same. The SKF is obviously probably going to be a higher grade metal than the C place, but these C place bearings are getting pretty good these days. As long as you get one that has a metallic cage, okay. The OEM bearings are high quality, but they do have a nylon cage, and when that nylon cage comes apart, then all your bearings are just rolling around willy-nilly, and you got big major bearing play. So the metallic cage is pretty nice. These usually don't fail. I wouldn't have any issues running either set of these, SKF or made in C, on a saw like this, on a clamshell homeowner saw like this. If we were doing the commercial version of this saw, which is the MS390, all day long we're putting SKF bearings in, no questions asked, because that's a split case to replace the bearings. That's a split crankcase, magnesium. And we're always going to put the highest available grade bearing in a saw like that, in that application. Okay, we've got a couple things to check before we go to assemble. So first thing, this does not take very long. First thing we're going to do is put our ring. We're going to just slide our ring into the bottom of our cylinder, and we're going to figure out what our ring end is. This is a 6 thou feeler, and I can fit a 6 thou feeler in there just barely. So we want about at least 5 thou for this saw. If you don't have the gap that you need, you take the ring out, you'll just wipe the end of it or rub the end of it on some whatever, 100 grit sandpaper or whatever, or a file, until you have the gap you need. If you have too much gap, if you've got 10 or 15 thou gap, it'll work, but you're going to have blow by. All right, the next thing I'm going to do is check my bore. The easiest, quickest way to check my bore, I already have my decomp plug in. So what I'm going to do is put my finger over the spark plug hole right here. And then in order to check my quick, easy way to check my bore, I'm just going to do a drop test. Drop the piston in. And if it drops down into the chamber about that fast, it should take about 2 seconds for it to, after the transfer is closed, then it starts going on, floating on air. Okay, so if I'll take my finger off a little bit. If it drops that fast, our bore clearance is a little greater than what we want. And if it doesn't drop at all, if it's kind of just stopping and hanging up or barely moving, then our bore clearance is not sufficient. And then what we would have to either make an adjustment to our piston or get a different piston. Just gonna clean up with some Scotch-Brite the crankshaft where the bearings go on. Get any caked junk off of there. And then we'll put the bearings on. All you gotta do is put a socket on it like this and then give it some taps. And our bearings seated on. Let's go ahead and put our piston kit on. So this kit came with this kit came with a new wrist pin bearing, a new wrist pin, and obviously a new piston. Now we're going to make sure we put this on in the right direction, because this is not an ambidextrous piston. This has to go arrow out the exhaust port. It has to, or it will not work. Well, I can't say for sure it won't work. I've never tried it. I would assume it won't work. Probably hook a ring. Oh. All right, and then we're just going to put our wrist pin clips on. You know, some guys like to, after they put these clips in, they like to cut this little ear off. You know, some people have a lot of issues with wrist pin clips falling out. You know, knock on wood, I've never had a wrist pin. I don't know what these guys are doing that these wrist pin clips are always falling out. I've never had one fall out. You know, I hope I never do, but I've never had one fall out. I think a lot of it has to do with the orientation of it. I always orientate the opening at to 12 o'clock. All right, let's go ahead and put our rings on. The ring does have an up and a down position. You can see where the ring copes around the pins. The ring does not matter. The rings are both the same. They do not matter if they go on the top or the bottom. Be gentle with the rings. You can break a ring if you're not gentle with it. But if you spread the ring out, it should go right on. All right, the bottom of the cylinder is pretty tapered, so you should be able to just get it. It should just push, the ring should just push itself in. Okay. As far as sealant goes, the most important part is cleanliness. What do they say? Cleanliness is holiness. I'm going to clean the mating surfaces with a rag and brake clean. Make sure we get all the oil residue off, all the gasket surfaces. As far as the product goes, a lot of people use the Permatex Moto Seal. I like it. It is like thinner and more runny. So for some applications, I like this because I know that it's not going to squeeze a big fat bead into like my quad loop transfers and stuff like that. Other people like 3-Bond. A lot of people like Durco. There's Yamabond, Honda Bond. Essentially, you just need a fuel resistant. You know, a lot of RTVs and stuff are oil resistant, but they're not fuel resistant. So you're supposed to use a fuel resistant sealant. Now, all right, so now we're ready to seal. So I'm just gonna squeeze out some of my 3-Bond or Moto Seal and kind of stir it, because you'll see it kind of come out different colors squeezing out of it. So I'm gonna kind of stir it up. And then what I'm gonna do is take one of these little modeling brushes, because you can buy a pack of these from Walmart or wherever. They're $2 for like a pack of 20 of these little modeling brushes. And then what I'm going to do is I'm just going to start painting with my piston already started inside the cylinder. I'm going to start painting up the surfaces of my my sealing surfaces. So I'm just going to come in here and just start painting it up. I like to run right through the seal. Seal the seal. You just make sure everything is covered with a nice thick layer, you know, get the strings out of there. And then we're going to do the same thing to the bottom of the cylinder. And you know, you can turn it around and do it however, you know, whatever works for you. Turn it all the way around. And we're going to have essentially then, you know, after a few minutes we'll have two liquid gaskets that are kind of skinned over a little bit, but that's okay. And then we'll press them together and we'll go and put our screws in through our plastic carcass. All right, I got all my painting done on both surfaces. And there's all these little stringers that come off that stuff, and that ain't gonna hurt nothing. So now with my seals and everything assembled, I'm gonna just kind of push this together for the final time. And make sure my seals are in the pockets where my seals need to be. All right, we got our clamshell reinstalled now. So I'm just gonna go in with my T27 and just kind of go back and forth, snugging this up. Make sure we can get that bar stud back in. Before we go nuts, make sure that we can get that bar stud back in, and then that can start. All right, that's good. And now we're just gonna go kind of do a finished torque. You wanna follow torque specs, go right ahead. You don't really need any Loctite or anything because steel screws are self-locking. Never seen any of these back out, ever. You wanna put Loctite on, go right ahead. Ain't gonna hurt nothing. We're gonna just keep going back and forth, back and forth, back and forth, till you think it's tight enough. Or you wanna follow some torque spec, go right ahead. And then we're just gonna kind of do an inspection here. Do we look like we're all closed up, tight, with sealant squeezing out, around, just like it is? All right, well, you've seen me take it all apart, so you know how to put it all back together. There's really no tricks or anything that I can think of. All the parts go right back on the way that they came off. our saw runs, you know, that's about all we're gonna get out of a mildly modified 290 390 build. And that ring might set in a little bit more, you know. And this is it's probably one tank through it right now. So they say, you know, 2-3 tanks that ring sets in, and then you get what you get for compression out of it. So we could add a little bit more torque. It's never gonna have as much torque as a 360, 361, 362. It's just not designed to. I mean, and you can do machine work and grab more torque that way, but you really, in my opinion, you don't want to do that, because it's not built for that. It's not designed for that. It's designed for cutting stuff like this up and making firewood. And so that's probably all we're going to get out of it. And I want to do a part 2. Let's get that other one together, the stock 290 390. That one's going to have the 390 top end on it too, but it's going to be, we're not going to do any of the modifications to it. And then we'll see, is it 1 second faster, 2 seconds faster, or did it do nothing, or is this one slower? Did we screw it up? So let's find out in part 2. And one last thought, I might have been wrong about that muffler. You know, you can definitely get them barking a lot better if you take that baffle out of the center. They do just get really loud that way, but you know, there's probably a little bit more juice. It's probably got a little bit more juice if we were just totally to gut that muffler out. But that's one of those things too, where if you're gonna sell a saw to a buddy or something, you know, he may not want a totally gutted muffler. You know, we're not trying to race the thing. He's trying to make a nice firewood saw, you know. So you know, it's one of those things that it's really personal preference on the muffler. So thanks for watching, and we'll see you soon.